Okay, so question 4 here, we often get this sort of question in the exam where it says to show that these two vectors are perpendicular. If you remember, perpendicular means that they will intersect each other, okay, they'll cross each other at 90 degrees, okay, that's what perpendicular means, yeah, 90 degrees. Okay, now if you remember the angle formula from before, okay, we had that in me, and that's what you've got to remember for the exam. But what's good is, if you put 90 degrees in there, right, you know that cos 90 is just 0, okay, so putting 90 as an angle, you get 0 here, okay, right, which means 0 times the mod of these will just be 0. So all of this just disappears. So you end up having a dot b equals 0. So you don't need to work out the modulus of a, modulus b, to show they're perpendicular. You just need to show this. If you can show that a dot b is 0, they're perpendicular. Okay. So just remember that in the exam. Okay. You know, if you don't need to go through all this in the exam. You just need to say, look, if I dot these two and it comes out to be 0, it's 90. It's perpendicular, right? It's 90 degrees. So in the exam, literally, all you're going to write is 3i minus 2j plus 2k. So we're going to dot that then with the other vector, 2i plus j minus 2k. So if I work that out, and remember, like we did before with the dot product, you times the i's, so 3 times the 2, which is 6. I's disappear. The j's then minus 2. And there's 1 there, so that'll be minus 2 times 1 is minus 2. And then the k is 2 times minus 2, which is minus 4. And it equals 0, okay? So you do that in the exam, and you've shown, like, look, you literally can say the statement, look, a dot b is equal to 0. Therefore, vectors are at right angles, yeah? So perpendicular. And it's job done, 2 marks.